Welcome back as we conclude this program with some important operating checks. Air-cooled units depend heavily on a steady and continuous airflow across the condenser's cooling coils. Any hindrance to airflow or heat transfer to the atmosphere will result in poor performance. Poor condenser performance can be caused through dirty fins, corrosion, and a malfunctioning cooling fan. Dirt or grime upon the cooling fins results in a blanketing effect and reduces heat transfer to the air flowing around them. Corrosion often occurs where the metal fins are joined to the tubing. Heat transfer through this corrosion layer is poor, and this results in reduction of heat rejection. When airflow stops, for example when a fan motor fails, then heat loss is limited to convection only. This form of heat transfer is far too slow for commercial units, and efficient condensing will not occur. Classic symptoms of poor condensing include bubbling in the sight glass, a temperature rise in the lower coil outlet, and a rise in discharge pressure. Condensers often receive the odd knock, which bends the fins. Fins in this condition should be straightened to improve the airflow. Straightening of fins requires a fin comb and a great deal of patience. A badly corroded condenser can seldom be repaired. Renewal is the only solution in most instances. Keeping the condenser clean and free of debris is an essential routine in any maintenance plan. Very little maintenance is required to the rest of the unit. However, we would check other components periodically. Let us overview some typical checks. Beginning with compressors, the most important check necessary is the oil level. Oil should always be visible in the sight glass. If no oil is visible, the system will require a full inspection to discover the cause of oil loss. The expansion device requires no maintenance and must not be meddled with. Evaporators seldom require attention. However, the fans, where used, should be checked for correct functioning. Filter dryers normally need only be replaced after a system has been opened to atmosphere. On the rare occasion that a filter becomes blocked or restricted, you may see bubbling in the sight glass. To test a filter, take a surface temperature measurement across the unit. There should be no appreciable temperature difference. The filter must be renewed when a temperature difference exists. Periodically, it is wise to perform a leak detection check using any of the methods described in the previous module. Further, it is recommended that pressures be checked on routine inspections using your gauge manifold to determine whether the system is operating optimally. In the event that you need to shut down a system while it is in operation, then the following procedure is recommended. Begin by closing the liquid line solenoid valve, or alternatively, front seating the service valve on the receiver. Allow the unit to operate until the suction pressure falls to the preset cut-out pressure, whereupon the compressor should stop. Isolate the unit via the main supply switch. This procedure, known as pump down, causes the refrigerant to collect in the receiver and in the condenser line, thus starving the evaporator. In this way, we prevent oil slugging in the evaporator during an off-cycle. This concludes this introductory series. With time, your own experience will equip you to master the many skills required in the wide field of air conditioning and refrigeration maintenance and repair.